everyone. So today we are going to discuss the very important topic of the balancing, and that topic is the balancing of single rotating mass. So before going on directly on my topic, I just want to brief about the previous lecture of the balancing, which was the static and dynamic balancing. And in that static balancing, the system will be in static balancing when the net summation of the forces or the vector sum of the forces on the system is equal to 0. And for the dynamic balancing, the net summation of the force as well as the net moment, that should be equal to 0. So now we will go to the balancing of the single rotating mass. Okay. So in this topic, suppose there is a shaft which is attached between the two bearings, and the disturbing mass m1 is attached at the radius of r1, and the shaft is rotating with the omega angular velocity, and because of this rotation, a centrifugal force is generated in the outward direction, and the magnitude of that centrifugal force is equal to the m1 r1 omega square. So this centrifugal force creates the disturbance in the system, and because of that disturbance there will be the unbalance in the system. Okay, so now we have to balance the system. So basically there are two methods by which we can balance the system. So number one is by providing a single balancing mass in the plane of disturbing mass but directly opposite to the disturbing mass. Number one. And the other method is by providing the two different masses into different plane but directly opposite to this mass. Okay. So we will go one by one. The first is the balancing of single rotating mass by the single mass. Okay, so suppose this is our system in which the disturbing forces is the m1 r1 omega square. So now we are adding the balance mass m at the radius of r, and because of the rotation, because of the omega angular velocity, the centrifugal force will be generated on the balance mass, and that centrifugal force will be equal to the m r omega square, right? So now the system will be balanced when net summation of the force is equal to 0, or we can say the vector sum of the forces is equal to 0. So mathematically we can say the system will be balanced when m1 r1 omega square, that should be equal to the mr omega square, right? So we can say mathematically mr omega square is equal to the m1 r1 omega square. Since both masses are connected on the same shaft and shaft is rotating with omega angular velocity, so we can say the omega is same for the both masses, so we can cancel it out, right? So here the conclusion of this is mr is equal to m1 r1. So we can find the balance mass for the different value of the valence radius. Okay, or we can say we can find the radius of the balance mass for the different value of balance mass. Okay, so here we can find the balancing mass. Now we will go to the balancing of single rotating mass by the two different masses. So okay, so suppose now we have to balance this mass by the two different masses, and suppose these masses, the first mass is the mb1 at the radius of rb1, and the other masses is mb2 at the radius of rb2, and these are at the two different plane but directly opposite to this plane, this mass. Okay, and because of the rotation of the shaft, the centrifugal force on this mass is mb1 rb1 omega square, and as on this mass is mb2 rb2 omega square, right? Now the distance between distance between the disturbing mass and the first balancing mass is considered to be the L1. The distance between the disturbing mass and second balance mass is to the L2. The plane of the first balance mass is considered to be the A, this is B, and this is C. Now the distance between the A and C, that means the distance between the two balance mass is considered to be the L. Okay, so the system will be in balance when it satisfies the two basic conditions. The first condition is the net summation of the force is equal to 0, so consider to be the equation number 1. and the second condition is when the net moment acting on this system is equal to 0. So this is considered to be the equation number 2. So by the equation then, so first we will go by the equation number 1. It's considered to be the net summation of the force equal to 0. So we can say that this force will be equal to the summation of this and this. So by equation 1 we can say m1 r1 omega square is equal to mv1 rv1 omega square plus mv2 rv2 omega square. Omega is same for the all three masses, as all three are connected with the same shaft and shaft is rotating with omega angular velocity. So omega square will be cancelled, and here m1 r1 that will be equal to mv1 rv1 plus mv2 rv2. This is the equation number 3. The second equation, which is the net summation of the forces, the net summation of the couple. So first we will take the moment with respect to A, then we will take the moment with respect to C. So by equation number 2, by taking the moment with respect to A and putting is equal to 0, so the moment of this force that will be equal to 0, and the moment of this force that will be equal to the m1 r1 omega square into L1, and the moment of this force is equal to the mv2 rv2 omega square into L. Now this moment is in anti-clockwise direction and this moment is in clockwise direction. So this will be equal to this moment. Okay. So m1 r1 omega square into L1 is equal to mv2 rv2 omega square into L. यहाँ से from here omega square will be cancelled, and we can find out the product of mv2 and rb2. So the product of mv2 into rb2 is equal to the m1 r1 L1 divided by L. This is the equation number 4. So now taking the moment with respect to C and putting it equal to 0, so there will be the two moment. Number 1 first, which is equal to the m1 r1 omega square into L2, and the second moment is equal to the mv1 rv1 omega square into L, and both are in the opposite direction. So moment of this force equal to the moment of this force, right? So similarly, the moment with respect to C is equal to 0. So m1 r1 omega square into L2 is equal to mv1 rv1 omega square into L. Omega square will be cancelled, and from here mv1 rv1 is equal to m1 r1 L2 divided by L is equal to mv1 rv1. So by equation 3, 4 and 5 we can find the balance mass mv1 rv1 and the radius of the balance mass rv2 and rv1. ओके, सो दैट्स एनफ फॉर द डे. आज के लिए इतना ही. अगर आपको ये लेक्चर में कोई डाउट है तो आप मुझे कमेंट में लिख सकते हैं, और अगर आपको ये लेक्चर पसंद आए तो लाइक कीजिए, शेयर कीजिए, कमेंट कीजिए एंड सब्सक्राइब कीजिए. थैंक यू.